All right. The child's swing in figure. Can anybody here understand what that picture is supposed to be and how in the world that's supposed to be a child swing? Because if this is a child swing, whoever's in charge of this child should be reported to protective services. Is it? Wait, okay. It says the figure in 828, the child's swing is held in position A and released from rest.
Maybe it can slide.
Okay. Okay.
It's accelerating.
Well, I guess what I'm gonna assume is that we don't want the child to die, and because of that, it's going to start here and okay, it's gonna go away. Stop that. It's gonna start here and swing down through there. So all they're showing us is that these two are on that arc, right? And then A and B must also be on that arc. So at some point they're swinging there. I can't understand. Basically, oh, you know what? Okay, just take this and turn it upside down. No, because you can't turn it upside down because then it wouldn't swing anywhere.
Is that like the height swing?
I'm interpreting it as this, with A being here and B being here. And it swings that way,
This problem.
right? Well, I read it, makes total sense, but then I look at the diagram, I'm like, what the heck? Okay, so, I mean, the problem's pretty straightforward, actually, though, because the kid has a mass of 0.7, what? Oh, the swing. Hello! I'm Thumbelina. Okay, so the swing has a mass of that. What's the total force exerted on the swing by the ropes? So basically, at the bottom, we just got to we have to do the force diagram, T and Fg. And so we say T minus Fg equals mv squared. Okay, what is that? mv squared over r. Okay. Did they give us a radius? So the best we can do at this point is just say the tension is going to be equal to mv squared over r plus mg. Oops. Does that part make sense? We actually did this. I think we did this. We did some calculations together. Yeah, it seems to me they did not give us a radius. So then that's pretty much the best we can do. I don't see a radius.
They gave us an answer though, an answer.
Oh, they did? What's the number? 20.6 newtons? Okay, let me see. 20, so let's say 21 newtons. So if they give us 21 newtons, and this thing has a mass of 0.7 kilograms, that means what? F equals A is F over M, so 21 divided by 0.7.
They use energy.
But even if you use energy, you need R.
Did they somehow put R? Wait.
What did they put an R in?
Yeah. I'm not sure.
I don't know, they just, basically they have exactly what we have, and then they magically have a number.
Okay.
Physics, it's magic.
Physics plus magic.
You're not gonna figure it out for us?
There is no way to figure it out. I'm thinking this is some sort of type. Did anybody's problem have a radius in it? No? Yeah.
I think there's in the book there was some equation where v squared equals to g over v equals to gr. So then when you plug it in, you eliminate r.
V squared is equal. Oh, are you talking about v squared is? Oh, v squared is gr. That's for minimum vertical velocity. That's like if you're up at the top.
You can't do that though?
Well, because okay, according to them, if you do that, you'll get mg plus mg, right? Which means 2 mg, and that would be 14, but their answer is 21, which means this v squared over r for them has to equal 2g. Is that right? Yeah, let me think.
Then you get 20.
Yeah, because mass is 0.7, right? So this one has to equal 20, that one has to equal 10. When you add them together, you get 30 times 0.7, that's how you get 21. So their v squared over r has to equal 20. Right, so that's where they got their radius. I mean, because yeah, you can, for the v, you can use v as the square root of rg. That's what you're saying, because, well, yeah. Wait, no, sorry, just kidding. You need 2gh, 2gr. You need that for the radius. Oh, that's it. It worked. Well, that's magic. Look at that. Okay, sorry, I was stuck on minimum vertical velocity. This is kinetic equals potential energy, right? Did everyone see that? Remember this? Yes, it's recording. So then if you plug that in, then, okay, so if I do this over here, I think everybody was with me for this, mv squared over r plus mg. And then if you have any object that falls a certain distance, do you remember when we did this, k equals pe? And we said 1/2 mv squared equals mgh. So the m's canceled and we got v is equal to the square root of 2gh. If you take that and plug that into there, you get m times 2g, and then it didn't fall h, it fell r. So you get r over r plus mg. And then that means the r's cancel, and you get 3 mg, which equals 21 newtons. Oh, there you go.
Hot dog.
Yeah, hot dog. That's crazy. So, what is the lesson that we learned there? If you're stuck, go to energy. Yeah, always use energy. Oh, because of the v squared? Right? Take square root of 2gh, yeah, square root. Yes. Because then this becomes 2mg plus mg becomes 3mg. That's fine. All right, so quiz tomorrow. The quiz will probably, okay, you know what? I will make it very much like one of these problems. So I will model it off one of these problems. I won't be creative.
Did you model off number 84?
I guarantee you it will not be modeled